Evening, my dear students. So we will be talking about biomolecules. Today I will be talking about the structure of carbohydrates. In the last class we discussed about basically the what is biomolecules and other things. Okay. So before getting into actual class, let us look at some of the students you went wrong with my last CCP question. So that is what it goes like this. The last CCP question was this is the thing which was asked, what is the proportion of hydrogen and oxygen in a molecule of all members of carbohydrates? This was the question is asked. Okay. The option was D. Okay. This is what the thing on solution goes like this: carbon and hydrogen can form a molecule in any carbohydrates. They do not follow any ratio because the carbon has the property of catenation. That is what you have to know, that the carbon X and H2O Y. So that is what we look at the general formula. So because the carbon is having a property called as catenation, that means it can link with n number of molecules. So that is where the option goes with respect to D. So today we will be talking about what we call the structure of carbohydrates. Basically we will discuss. The goals for the today's class is what we call as the structural elucidation of the glucose. So what is the open chain structure? Okay. Then how actually the glucose structure was established. So that is what we talk about. Then we talk about the structure of fructose. So these two comes under the first category called as monosaccharides. So then we will be talking about oligosaccharides. So that means more than one monosaccharides which yields on hydrolysis. That is what we discussed in the classification of what we called as carbohydrates. So where we will be talking about maltose, lactose as well as sucrose. So then we will be talking about some of the polysaccharides. So all of you know that cellulose, glycogen and starch. So they are called as what we call as polysaccharides. So let us start with what we call as the structural elucidation of the glucose. Before going to the structural elucidation, one should know about there is a special components called as epimers. So this is very important because this is related to my last class. Okay. So what is that is here, if you look at the things, they have the same chemical formula, okay, but they are going to differ in a particular carbon where the hydrogen and oxygen linkage will differ. So if you look at the glucose, the D glucose, because all of you said in the last class we discussed, if the OH group is towards the right, then that is called as the D glucose. That is what you can see here, the OH is towards the right. Okay, when we talk about this. So now if you think for your the carbon containing the hydroxyl group which is next to your what we called as the functional group, okay. So where the H and OH is in the second position, okay, that is what you have to very carefully look at here. But when we look for the next compound, that is the one of the isomer of your glucose, that is D mannose, okay. So where you can find the second carbon, okay, where hydroxyl group is exactly inverted. But when you look for the third group where the third carbon, okay, so where you can find once again there is a change in the alteration when compared to the mannose, okay. That is where you have to be careful. That is what I am talking about, group number 1, carbon number 1, carbon number 2, okay, and this is carbon number 3. So if you look at all the carbon number 3 are same, but only in the second position especially of the carbon which is just below the carbonyl compound which gets changes. So those substances are called as epimers. So epimers are those isomers which differ in the OH group at particular carbon atom, okay. So next, coming to the structural elucidation of glucose. So this is more important. So when we look for the structural elucidation, first and foremost is we have to find out empirical formula. So when we look at the empirical formula, it contains C, H and O. But when we look at the molecular formula based on the empirical formula, when we calculate the composition by using the mole method which we had discussed earlier, so that yields us C6, H12 and O6. So this is the molecular formula which is obtained by looking into the mole fraction method of identification. So then, so we look for, so what are the other properties which we look, because when you look at the structure of glucose as we discussed in the earlier case, it contains carbonyl compound, that is why it is called as aldohexoses. Similarly, when you look for fructose, it contains ketoses, then definitely it contains a keto as a functional group. So now what we have to do, we have to look for how the presence of aldehyde group is detected, okay. So that is why if you want to see, so the linkage of the aldehyde group in the structure, if you want to see the hydroxyl group present in the structure, if we want to see the primary alcohol structure present in the structure, and how the carbon atoms are related. So this is what the structural elucidation talks about. First we look at to show how the carbon atoms are linked in glucose. So that is why the basic structure, if I want to write the glucose, that is why you write CHO, okay, CHOH 4 times, this is fifth one, then we have CH2OH, this is primary alcohol group. When this is treated with hydroiodic acid in presence of red phosphorus, okay, on prolonged heating, the aldehyde group, okay, which contains hydroxyl group in presence of the primary alcohol group, okay. So this gets converted into CH3, CH2, what we call as and CH3. So now we have 1 plus 1 2, then we have 4, thereby it forms N-hexane. N-hexane. So now when you look at this structure, that very clearly indicates there is the linking of this carbon atom, it is in the linear, there is no branch linkage between the carbon to carbon. So if I write this structure in the open chain, I think you all of you understand. So this will go like this: carbon, 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 carbon. This is the fifth carbon, then sixth carbon. So that indicates us. So this is the linking of the carbon which takes place in the glucose. So that is why the above reaction shows that glucose is not branched one. It very clearly indicates there is a linear structure of the carbon backbone exists. So this is one of the identification when we treat hydroiodic acid in presence of red phosphorus. When we heat the reaction of glucose, it converts into N-hexane. Okay. So I think you got the concept how the carbon are linked in glucose molecule. The next reaction, when we think of the presence of carbonyl group, okay, this is very important. I think you already studied the carbonyl compound reactions, especially with respect to the nucleophilic substitution reactions like hydroxyl ion, okay, and hydrazine, okay, and as well as phenylhydrazine. So that is where we are going to make an interaction of this aldehyde group. The presence of aldehyde group can be easily detected by treating the phenylhydrazine, because the phenylhydrazine is an organic compound, it cannot easily soluble, hence we take the acid media so that it can form an adduct, and hence it is able to react with the aldehyde group. Thereby it is going to form a special compound called as phenylhydrazone. So this is what the indication that any nucleophilic, especially the carbonyl, when it is treated with, they are going to form hydrozones. So then further it is treated with the excess of the phenylhydrazine, so then that will convert into glucosazone. So this is the ozone formation takes place. That is where once again it is very important, but majority of your objective questions will land up with this, that when D-glucose is treated with, okay, 2,4-dinitrile phenazine, what is a phenylhydrazine, what is the product is going to form. This always gives D-glucose phenylhydrazone. That means the glucose converts into hydrazone format. That is what indicates the presence of aldehyde group. So this, especially this reaction is shown by only the carbonyl containing carbons. So either it can be aldehyde or it can be ketone. So the next structure, so this goes like this. So when we treat the presence of aldehyde, you all of you know that aldehyde reaction is like this. Whenever we treat aldehyde with respect to oxidizing agent, we expect, so there is a formation of the acidic product. That is means the aldehyde gets converted into acidic group. So that is why, so we have two types of reactions. One is the mild oxidation of glucose with the bromine water. Okay. So once again, if I take a structure of glucose, that goes as CHO, CHOH 4 times, so then CH2OH. So you know that this is your D-glucose. When it is treated with the bromine in what? Okay. So that gets converted into the aldehyde group which is present over here, gets converted into acidic group. So that means you are going to get gluconic acid. So you remember here the gluconic acid, that means the primary alcohol group present in the structure is not going to get oxidized, only the aldehyde group which is present in the glucose gets converted into acidic group. So, that is what the importance whenever it is treated with mild oxidizing agent. Suppose if we go with the same thing, strong oxidizing agent, that what if I take CHO with the CHOH 4 times, then CH2OH, when this is treated with like nitric acid, a strong oxidizing agent, or the potassium dichromate, such kind of oxidizing agents. So, then you can expect both the groups, that is aldehyde group as well as the alcohol group which is present in the bottom, both will get converted into acid group, that means COOH, CHOH 4 times, then it gives COOH. So, this is called as glucaric acid. If you remember, earlier one is called as gluconic acid, ONIC, when it comes to the strong oxidizing agent. So, that is what you can see, mild oxidizing agent will give you gluconic acid, when it is treated with the strong oxidizing agent it will give you glucaric acid. This indicates the glucose contains terminal primary alcohol group. So, that is what is very, very important. That means, we identified the linking of carbon atoms, then we looked into how the presence of aldehyde group is detected, then we discussed about how actually the alcohol primary alcohol group is present is also discussed. So, then to show about the presence of hydroxyl group, that means, we have detected aldehyde group, we have detected alcohol group, we detected carbon, then we left with only the final thing is the hydroxyl group. So, that is where in order to detect this the presence of the hydroxyl group, so this molecule, that is glucose, is treated with the 5 moles of acetic anhydride. I think all of you know that acetic anhydride is obtained basically when the acetic acid is heated, it undergoes the water molecule elimination and it forms acetic anhydride. So, when you treat that acetic anhydride, because it is already deficiency of the water molecule, then it allows or it reacts with the hydroxyl group to form pentaacetyl derivative of glucose. So, that is what you can see, wherever the OH group was there. So, the acetate ion, that is acetic anhydride, has formed a complex. So, that will give us glucose pentaacetate. This is the reaction which clearly indicates that contains the 5 hydroxyl groups. Okay. So, now coming to the structure of the next oligosaccharide, that is what we call as monosaccharide, that is the fructose. So, when we look at the fructose, so you can find out here there is a keto group and as well as it contains the 2 primary alcohol groups. When this undergo for glycosidic linkage, thereby you are going to get the structure that is called as pyranose and furanose. These are the 2 structures which are named after the Haworth structure. Okay. So, that means, if you find the 5-membered carbon, so here the 5-membered structure ring, so then it is called as furanose structure. When we get the 6-member, that is called as pyranose structure of the glucose molecule or the fructose. Especially when we think of fructose, we are always we expect the furanose structure because it is a 5-member ring structure. So, this is, if you look at carefully, how actually the linear chain of fructose undergoes what we call as the ring structure formation. So, there also if you look at, there is only change in the location of your hydroxyl group. So, that is where is very, very, very important. So, that means alpha D fructofuranose and alpha D fructopyranose, but this D, what I said, it is with respect to OH group, but when we look at the optical rotation of the glucose, so the optical rotation, it is levorotatory. The natural fructose is levorotatory. So, that is what you have to remember, because that is what more important, how actually this glucose gets converted into what we call as levorotatory substance and it becomes stable. That is where we talk about mutar rotation in later hour of my class. The next thing, when we think of what we called as this fruit sugar. So, actually this fruit sugar is identified and what are the properties it exhibits. So, when we think of this fruit sugar, this is also contains anomeric carbon atoms. So, that is what we discussed in the last class. So, when I write the structure of your what we called as the fructose, okay. So, there will be CH2OH, then you get C double bond O, so then you get CHOH, so then you get CH2OH. So, now there should be 6 carbon, now you have 1, 2, 3, so 4, 5 and 6. So, then it should be 2. So, thereby you are going to get 1, 2, 4 and 5, thereby it becomes 3. Okay. So, now this is the structure of your fructose. When we look for this, the commercially available fructose by hydrolysis of insulin. Okay. So, that is why it melts at 104 degrees. So, that is what is very important, and sweetens all sugars, that is what is very important. And when we look for the fructose, what we call as the specific optical rotation, this will have a special property. Okay. So, now one of the important property of this glucose, it undergoes reduction. So, what it happens? So, when it undergoes a reduction, so that is where when if you write a structure of fructose CH2OH, C double bond O, then you get what is called as CHOH thrice, then you get one more the primary alcohol group at the terminal end. Okay. So, then it is treated with a reducing agent like sodium amalgam. I think all of you know that it is a high what we call as the reducing agent which can donate the protons, that this reaction can occur only in presence of water. So, what do you expect the product here? Because whenever we add the nascent hydrogen or the protons, okay, so you expect the reduction product. What will be the reduction product? It will give the two products, that is what we call as sorbitol and the mannitol. So, these two are very important application in medical sciences. So, what is this sorbitol structure? First one, that is CH2OH. So, then it forms COH and H. So, now you can see here. So, this hydrogen which is the protons by the reduction process gets added to the keto group and rest of the structure remains same. That is where you get a product called as sorbitol, HOH. Okay. So, this is called as sorbitol. Then it will give another product, that product basically makes CH2OH, okay, then you get COH with respect to H. So, that is why I talked about the epimers which I discussed in the beginning of the class. So, you can see here, so there is a conformational change of linking of your H and OH with respect to a particular carbon atom takes place, thereby it gives a different molecule and rest of the structure remains same CHOH, and it becomes thrice with respect to your terminal alcohol group. Okay. So, now this is what we called as mannitol. So, mannitol is one of the very good component which is used in what we call as medical industries or what we call as medicinal applications when there is an edema in the brain or when there is edema in the organs. So, this mannitol will be injected intravenous, so thereby the edema can be reduced. So, this is the one of the best application with respect to the mannitol, which is the one of what the epimer of your fructose. So, next we will talk about the what we called as oligosaccharides. I think you know that oligosaccharides are basically obtained by the combination of one or two or more than monomers. So, that is what we call as monosaccharides especially. If you look at the sucrose, you all of you know that sucrose is the basic source obtained from cane sugar. The molecular formula of sucrose goes as C12, H22 and O11. So, when you hydrolyze this sucrose, so it is going to give two important components. So, those are the glucose and the fructose, out of which one is dextrorotatory and another is levorotatory. Now, when these molecules are hydrolyzed, we get different molecules of this glucose and fructose, how they are joined together and how the what kind of linkage exhibits between these two monomers. Now, if you observe carefully, so if I number the carbon atoms, that is 1, 2, 3, 4, 5 and the terminal alcohol group contains the 6. Similarly, when I go here 1, 2, 3, 4, 5 and 6. Now, if you carefully observe, so there is a glycosidic linkage which takes place between the first carbon atom of this and with respect to this carbon atom. So, thereby with the elimination of water, it going to form a linkage which we called as the bridged oxygen between these two molecules. That is where it comes under the category of glycosidic linkage. Glycosidic linkage. Okay. So, now next we will be talking about what are the other special property of this. So, when we look into the special property, that is where I call this a simple method is hydrolysis. When you hydrolyze this, so as I said, it is going to give two products. So, one is the glucose and another is fructose. When we look at the optical rotation of your glucose, okay, that is what I represent A here. So, that is where glucose I represent A and fructose I represent B, so that you can understand very clear. The optical rotation of the glucose, which is called as plus 52.5 degrees, okay, that is where it is the dextro rotatory because of its positive sign. When it comes to levo, this is the minus 92 degree, this is called as levo rotatory. When this gets equilibrium, so then we get inversion of sugar. So, that means, so because of the positive rotation and because of negative rotation, they attain equilibrium. That process is called as inversion of cane sugar. So, when the dextro and levo rotatory are mixed together, the plane polarized light will attain an levo rotation. So, that is where the invert sugar, this sucrose, after getting equilibrium, so this will finally land up with the optical rotation of minus 20 rotation, that is degrees. So, thereby this after inversion of sugar, so this exhibits levo rotatory in nature. So, when come to the sweetness of this sucrose, you all of you know that the best sugar which we think of is the sucrose is the fruit sugar, that is why it gets the name fruit sugar also, as well as your what we call as sweetness of the sugar is measured by a special number sweetness index. How best it makes the sweet or how best the substance will make sour taste to the tongue. So, based on that there is a sequence of arranged the substances that is called as sweetness index. So, when you look at the sweetness index, the fructose becomes the highest in the what we call as the sweetness, then it follows the invert sugar, then it follows the sucrose, then it follows your glucose, then it follows the maltose, then finally the lactose, the other two oligosaccharides which I will be discussing with you people. Okay. The next chemical property, if I look at the sucrose, that is what we called as oxidation property. When your sucrose cetol H22O11, it is undergo oxidation. Okay. So, what the product we can expect? The product we can expect is the oxalic acid COOH with COOH. So, this oxalic acid is going to form in huge number, that is 6 number of oxalic acid, plus it eliminates the 5 molecule of water molecule. Next, if I do the dehydration reaction, that means the remove the water molecule or the hydroxyl molecule from this. So, that means C12H22O11 when it undergoes dehydration. So, this usually done in presence of sulfuric acid, because you all of you know that sulfuric acid likes H and OH minus heavily. Thereby, it is going to form a product called as 12 carbon, then it gives the 11 H2O. So, 11 H2O we cannot say directly, that is what usually we represent H2SO4 dot 11 H2O. So, this is the product which going, that means the entire sugar get charred, that becomes a fine powder particle of carbon atoms. Next, if you look for one special property of your fructose is like this. So, this is called as the fermentation process, okay, which is usually done in presence of certain enzymes. Okay, that is what we add usually the yeast, which contains a bacteria, which is a bacteria which contains two enzymes, one is invertase and another is zymase. Later it gets converted into what we call as alcohol. Okay, so that is why how actually the alcohol is obtained. The C12H22O11 when is treated with, the first one is the zymase, then followed by the invertase. So, this gets converted to C6H12O11 plus C6H12. So, this forms the glucose. So, this any of these glucose finally interacts with your invertase and converts into C2H5OH plus carbon dioxide plus water. So, this is the alcohol which is used, okay, in blending the petrol today. So, all power petrol which you are getting in the market, which is nothing but power alcohol, which is called as the blended with the gasoline, basically which we called as the petrol, which is blended with alcohol. So, that will increase the efficiency of your vehicle. That means, so this plays a very important role as a fuel part. So, that is what one of the best application of your what we call as sucrose. So, next we will be talking about another what we called as oligosaccharide, which is the maltose. As the name itself indicates, the molecular formula will goes with as similar to C12H22 and O11, okay, which is basically present in the germinating seeds, okay, and cereals, and it is can be commercially we can prepare this by using hydrolysis of starch. So, that is what one of the thing. The basic enzyme which is used in the hydrolysis is from the starch. That means, if I want to obtain from starch means I have to use a special enzyme called as diastase, which is the enzyme which makes the glycosidic linkage to break and gets converted into what we called as the maltose sugars. Okay. So, that is what once again very important. It hydrolyzes to give 2 glucose unit in the presence of enzyme maltase. So, that is one of the best important role of maltase, which makes, that means, if the maltase enzyme is not active, then you cannot break this maltose, that is oligosaccharide, even though we consume, it is unable to break down into 2 glucose units. The next oligosaccharide which I am going to talk about is the lactose. So, this is once again a very important oligosaccharide which acts as a source of energy. So, which also have the same formula, that is C12H22O11. When we look at the molecules here, if you look at carefully, okay, the carbon 1, 2, 3, 4, 5 and 6 here. Once again here it goes with respect to 1, 2, 3, 4, 5 and 6. Now, if you observe carefully, there is a trans glycosidic linkage when compared to other. That means, here you are going to get 1,4, okay, 1,4 glycosidic linkage. In case of lactose, when we think this is basically present in the milk, that is a source, okay, milk of all animals, and impart sweetness to the milk. So, hence it is called as milk sugar. Sometimes the lactose is also called as the milk sugar. It is manufactured by evaporating, so what we call as the milk proteins. So, that is one process which usually do, that is what we called as the fat content, the cheese as well as the casein will as to be removed, thereby the final remaining product which after crystallization will give us the lactose. Okay. So, this is lactose on hydrolysis gives us equimolar quantities of D-glucose and D-galactose. So, that is what you can see here, one is galactose and another is glucose. So, we are able to get the 2 hydrolyzed product as the galactose and one another is the glucose. So, next when we think of it is a reducing sugar, hence it can reduce the filling solution as well as the tolerance reagent to form the respective the ozone formation of the compounds. As I discussed in the beginning, whenever we find the free aldehyde group or the free ketone group, so that can interact with phenyl hydrazine to form hydrazone, phenyl hydrazone. So hence we can say that whenever the free hydroxyl group is there or what we call as the aldehyde group is there, so that is able to reduce, hence it acts as reducing sugar. Okay. So now with respect to this, I would like to go to the oligosaccharides. So then we are talking about the next important thing is the starch, which is called as the polysaccharides. So when we look at the polysaccharides, you can think of it contains a huge number of the monosaccharide units. It goes in terms of lakhs of the monomers are linked. When we look into this starch, so starch is basically insoluble in water. When it made hot, it becomes what we call as a colloidal solution. So this basically due to the presence of the two components which are present in the starch. One is called as amylose and amylopectin. So when we look for this presence, these components which makes, so what it makes insoluble. When you look at amylose, okay, so which is present about 10 to 20%, when it comes over here 80 to 85% roughly. So that makes this amylopectin which is insoluble in water, thereby the starch is insoluble in water, it forms a solution of suspension or what we call as the colloidal solution. And hence you can find here two types of linkages. One is the linear chain linkage and another is, if you observe here, the branched chain linkage, that is with 1,6 glycosidic linkage where it is in the branched chain, and if you look in the linear chain where you can find 1,4 glycosidic linkage. So the two linkage are exhibited by the starch. One is in the branched chain where you can find 1,6 glycosidic linkage, and in the linear chain you can find 1,4 glycosidic linkage. And one important thing is, when this starch find an important application in the what we call as iodometric titration, where the starch acts as indicator. When we add indicator towards the end of this titration, especially they will change the color. That is why the amylopectin which is present in the starch, it is turns red with iodine. When the amylose is present more, then it turns into blue. So that is what is important. The amylose which is contains less quantity, if it is okay treated with iodine, then the whole solution will turn into blue color solution. If the amylopectin is present more after hydrolysis, then the entire solution will turn into the red brown color. So this is with iodine reaction. That is why, so the starch, even though it does not have any other functional group except what we called as the hydroxyl group, hence it can act as indicator also because of a process called as adsorption of iodine onto these what we call as the glycosidic chain takes place. So that is why it changes its color. Okay. So now I will be talking about another important component, that is where we call it as the cellulose. When we think of cellulose, so this is a structural polysaccharide of plants. So when we think of the starch, it is the storage polysaccharides of animals, because that is what we get energy. But when we look into the cellulose, so this is also very huge structure which contains n number of the glucose molecule, once again where we find alpha and beta form, thereby you can find what we call as the trans variation in the glycosidic linkage. Okay. So then if you look at one more component where the glucose molecule, if it is attached with amide groups, so then in the cellulose they can convert into a special component called as chitin, which is very important, once again a polymer. Okay. So next is we will be talking about the storage polysaccharide of animal, that is called as glycogen. The glucose which gets converted into your electron transport chain, there we get into the Krebs cycle, glucose 6 phosphate, then glucose 1 phosphate, then by using so many enzymes, so this glucose finally converts into the glycogen. Whenever we take the food, what is the required amount of energy will be used by the body, and the rest of the energy which is synthesized during this process of ATP, or the glucose which is becomes excess, or the what we called as the glucose in the blood, if it goes behind the certain blood level, then it's try to convert into the glycogen that will be stored in the liver. So that's what you can see, the small glucose unit which were taken as a food, that finally makes a huge molecules of your polymer of glucose, and that will be stored in the liver with the certain enzymes. So this is where what we call as glucogenesis and glycolysis. Okay, so this is a process which you study much in biological system, but the conversion of this will be very, very important otherwise. So this leads to a disease called as diabetes mellitus. Okay, type 1 or type 2 of diabetes can be seen in the humans. So then let us look into what we call as the previous contest winner. So the Tamanna Sharma is the previous contest winner. So Tamanna, one atom session adds to your account. I think you are all waiting for the today's contest question. The today's contest question goes like this: how many optical active isomers are in fructose? Today's contest question I asked as goes like this: how many optical isomers are in fructose? So last class we discussed, I think you are able to do this. So the option given as 3, 6, 8 and 4. So your countdown starts as 3, 2, 1, 0. Okay. So now let us look at the previous contest question. Okay, the option answer is C, that is the 12%. The percentage of sugar present in Indian cane is, okay, the sugar, okay, they are talking about the sugar content. Okay, so the content of sugar is 12%. The answer is C for that. Okay. So let us continue with the today's topic, like that's what we are talking about. So we are coming to the end of the class. That's where we have discussed about all the structures of the carbohydrates. So basically we discussed with respect to the structural elucidation of glucose, then we discussed about the structure of fructose, then we discussed about the oligosaccharides like sucrose, then maltose, then lactose, then finally we discussed about the polysaccharides like starch, glycogen and cellulose. So I hope you understood the concept of this carbohydrate and its structure. So after my class, I think you all of you know that the passport users has to go for your CCP. The 10 most important questions based on the today's topics are given over there. So please answer them and ask your friends who are not passport users to log in, get into the access and answer those to get the better knowledge. Okay, thank you for joining with us.